Warning! Tube amplifiers have lethal voltages inside them. Please do not attempt to build, test, or repair these without understanding and following all safety protocols. Hey y'all! Well, today we're going to be diving into the last of this mod series, which is about the global negative feedback. Is what's in there appropriate? Does this 5.6K mod work, or is it making the amp unstable? Are there other better options? We're going to be putting this thing on the scope and the audio analyzer suite, seeing the results of the changes to the global negative feedback, and seeing how it changes the frequency response, which is interesting. Let's get into the testing. Okay, so we got our trusty Tektronix 2235 hooked up to the R8, and first we're going to look at the stock channel with the 33K feedback resistor in it, and I put a 5.6K in the other channel, which seems to be a fairly popular mod people are doing to it. And let's look at the square wave. So this is on the unmodified channel, and you can see there's a little bit of ringing here. And first we'll look at both the up and down to make sure they're the same, and then we'll zoom in on one of them to let you get a better look at it. And you can see as we come up, there's a pretty good bit of ringing. Right there is where it goes into clipping. If you drive it any harder, you can see it's not making any more power, we're just clipping. So if you look at it, it rings and then it stops fairly quickly. And this is a little more than I would like to see, but it's not horrible. And if you notice, as you go up and down, the ringing stays the same. And when it blinks right there, it's just losing the trigger because the signal's so low. But you can see like the ringing, as you come up, it gets higher in amplitude, but it stays the same. It doesn't change shape, which tells me everything's stable. The amp's running like it should. Again, I think possibly putting a small value, like maybe a 10 or 20 PF capacitor across that resistor, might dampen some of this ringing a little bit. And let's magnify this a little bit so you can see more what I'm talking about. Right there where it stops, that's clipping. But as you come down, like that's probably half volume. And at half volume, there's very little ringing. And it symmetrically grows up to full power. Honestly, I'm not real concerned about it because most of the time you're going to be listening to the amp around that volume level, or most people will. And that's not going to be a cause for concern. So let's look at the sine wave. And as we turn the amp up, you can see it starts clipping right there. And we have, this is the input from the signal generator. This is the output into the 8 ohm dummy load on the output. And we have the input set on 1 volt per division. So it takes 1 volt of signal to drive the amp to clipping, which is pretty sensitive for the front end of an amp. To have 1 volt peak to peak will drive the amp to full volume. And it's probably what we're noticing from people saying that the amp seems almost overly sensitive or has too much gain on the front end. So let's switch over to the other channel that has the 5.6K feedback resistor in it and take a look at that. We're back on our square wave, and as you can see, we're at very low volume and we've got a ton of ringing already. And let's zoom in here so we can see what's going on. I mean, as soon as we start getting enough where it just triggers the scope, we got ringing. Now watch what happens when I turn it up. This isn't staying the same. Look how it's inverting in on itself and like flipping upside down and then doing a little weird thing there on the top end. But look how it like folds in on itself as you're turning it up. That's not normal. Honestly, I've never seen a square wave do that. So that's telling me this is just way too much negative feedback. And again, as soon as we get enough signal going into this where the scope will trigger and show correctly, it's ringing. And that's almost no volume. So you're going to have ringing and weird stuff going on running that 5.6K. And I know some people on the forums are saying that it's more accurate and it's more reproductive of what the artist said. And it's not even close to representing the input signal, the square wave that's going in with that much negative feedback. So let's look at the sine wave. So on the sine wave, when we look at, there's where the amp starts clipping. With that low value feedback resistor, it does reduce the input sensitivity. And now it's a little over 2 volts peak to peak going in to get the amp to clipping. So it's effectively cutting the input sensitivity in half, but I think that the weird square wave that we're seeing come out of this is not the way to reduce the input sensitivity. I think putting some sort of a resistive voltage divider on the input of the potentiometer is a better way to reduce the input sensitivity. And honestly, I'm wondering if this amp might not perform better with 6S7 tubes configured to run as the voltage gain. But that's way more work than I'm interested in doing to this amp. So, guess I'm at this point where I'm thinking this 5.7K mod is not a good idea. I'm not seeing the amp go totally unstable, but I'm also not seeing a clean signal coming out of the amp with that much negative feedback. So we're going to come in here and test one channel versus the other. This first one is the factory setting the 33K feedback, and let's see what we get THD versus power. And this line right here is 0.1% distortion. That's 1 watt right there. And this is around 5 watts right here. That's the 10 watt line. And we're still at 0.3%, 0.5% distortion at 15 watts. Levels out here. And 1% distortion. Got 43.5 watts. 2% distortion. Got 45 watts. So that's what we were seeing before. And I mean, this is kind of what I would say is max power. That this is where the, it just turns up. And that's 41 watts. Or 42 watts, it looks like. Which, good power. This is with the KT88 Gold Lion tubes. Running in ultralinear. So now let's see what the other channel does that has the 5.6K resistor in it. And we are seeing lower distortion numbers. But honestly, when you're seeing less than 0.5% of distortion in a tube amp, you're not going to hear that. And it's probably actually going to make the amp sound a little better, because that's why we listen to tube amps, is for that sweet harmonic distortion. And we lost almost 10 watts of power. I mean, we could kind of cheat here and go with this 2%, which is clearly, when the line's going vertical like this, you're into clipping. And it's going to sound distorted. And even at 2%, we're at 37 watts instead of 45 watts. And down here, right when the clipping starts, we're at 35 watts. So we've lost about 8 watts of power. And that's not input sensitivity differences. The software is capable of putting out like 2 volts RMS if it needs to drive an amp. So we're not running out of steam on the input of the signal generator. We're running out of drive inside the amplifier because we've got too much negative feedback. So last thing I want to check is the frequency response curve. I'm not sure. Let's try pulling on both channels, but they have such highly different input sensitivity. I'm not sure how this is going to work. When we did pull both of them, you can just see that this one's down at a lower volume level than this one is. And I mean, they both look flat. That's at 20 hertz. The one with the extra feedback seems to have a little flatter frequency response, but that weird square wave just bothers me. And I feel like that maybe there's a compromise between the two. So I think I'm going to come back and try something around a 16 to 20K resistor and do another look at the square wave, and then tune on that with a capacitor across it to see if I can smooth it out and try to find a compromise between these two extremes. Okay, so I've been playing around with some resistor combos, and I wanted to be careful of not inserting too much feedback and killing power. So I put a 24K resistor in, which is about 30% smaller than the one that the amp comes with. And I was still seeing a lot of ringing. I tried some different capacitors, and honestly I don't have a great selection of these small PF capacitors. I tried a 10 and a 24. They didn't do a whole lot. Even the 100 didn't do a lot. And the only other small one I have is a 330, and it seems to have cleaned up the square wave. So let me show you what that looks like. And as you can see, it only starts ringing when you crank it all the way up. And up until that point, it's pretty clean. And so I'm going to go see what this sounds like. This is a huge improvement over what was in it. And depending on what it sounds like, I may order some 220 PFs and kind of split the difference between the 110 and this 330. But it still has a little bit of overshoot, and that's usually something that sounds good. You can see if you look at it closely, right here it goes a little past the line. It goes a little up past the line and then just settles right back down. And so this should sound good. I'm going to do the other channel, and before I do that, I want to run it on the Analog Discovery 2 one more time and make sure that we're not killing like 10 watts of output, and then go listen to this thing and see what it sounds like. So now we're going to do a THD versus power, and I'm going to go ahead and see how it does doing both channels at the same time. The red is the one with the 24K and the capacitor across it. And they're tracking very similarly. The red's lagging a little behind because it does have a little more feedback and less input sensitivity. And as we go past 10 watts, they cross, then they cross back. And they're making the same power. When you're right there, right where they turn up, they're both making about 40 watts. And then, you know, if you get into the higher distortion levels, there's 43 watts. So, for all intents and purposes, that resistor and capacitor is not harming the power output of the amplifier like that 5.6K one was. So the last thing I want to do, and this is going to be the most telling to me, is I want to see what the frequency response curves look like with the 33K with no capacitor and this 24K with a 330 PF cap across it. And again, the red line is the lower value resistor with the capacitor and slightly reduced input sensitivity, so it's going to track below the other one. And wow, look at the difference in that. Check out this blue line, and right here at, let's check them both at like 40 hertz. At 40 hertz, we got 34.15 dB. And then at 10K, there's only a half a decibel difference on the channel with the 24K resistor and the 330 PF capacitor. Now on the other channel, got 35.13. Got a whole dB of difference between the 10K and 40 hertz on the channel without the capacitor. And as you can see, when it goes past 10K, you get another couple of decibels of brightness. I think we may have hit the feedback in the sweet spot. It looks like a pretty flat frequency response curve, and just have to go see what it sounds like. And again, I can always back off that capacitor just a breath to kind of split the middle between it and that 110 PF if I need to. But I have a feeling this is going to sound really good. So anyway, there's the readings, and let's go plug this thing into some speakers, and I'm going to do some final thoughts on this negative feedback. Well, as you can see, the RA is no longer on my bench. It's at the owner's house. Took it over there last night, delivered it. We listened to music for several hours, playing around with different setups, different tubes and stuff, and I'll go over that in the kind of final video about the whole, what we did, what I recommend, and all that stuff. But this one we're going to focus on the global negative feedback. First, on that 5.6K mod that I've seen people doing, or you may have already done your amp. I didn't see that making the amp like totally unstable, or there was some crazy oscillations. And I didn't get into every scenario like long cable runs with higher capacitance that could cause instability, but I just feel like that's probably a little too much, especially when I see the impact it had on the output of the amplifier and the distortion kicking in at a lower power level. I think that's just too much global negative feedback. I feel like this 24K from 33K that I did is a nice compromise, that we're adding a little bit of global negative feedback that helps reduce the distortion a little bit without making the square wave doing crazy stuff as the voltage went up, or having the ringing kicking in at a really low volume level, which is the problem I saw with the 5.6K. Even at a few watts, you could see a ton of ringing on the square wave on the oscilloscope that I wasn't seeing with the 33K. And when you're seeing ringing in the output square wave that wasn't in the input square wave, that's not more realistic sound. You're not creating a better copy of the input signal when you're seeing that ringing. So then I started playing with putting some small value mica caps across the resistor, and I've seen in some amps even 10 or 20 PF seems to have an impact. Saw no change in the scope pattern. Didn't make any difference at all. When I went up to 110 PF, then I saw a difference. Started to see some smoothing of the square wave ringing. When I went to 330 PF, the ringing was gone. Totally cleaned it up. When I listened to the amp with the 330 PF cap in it on my system, and God, what a nightmare carrying that thing back and forth upstairs and downstairs, soldering one thing and putting it back in, but I digress. Through that process, the 330 PF on my system, in my house, with my source, sounded a little flat. I'm not going to really say dead. It just sounded a little flat. And the top end sparkle wasn't there. So, unfortunately, I didn't have a 220 to try, because when I tried the 110, the sparkle was back, but it might have even then been a little bright. And when I took the amp over to my friend's house with his speakers in his house, it definitely sounded a little bright. We were able to get rid of some of that, doing some tube rolling and putting those GE6SL7 tubes in that look like this. Brought back some of the bass and toned down some of the sparkle that was a little excessive, but I honestly feel something like a 220 PF might be the magic number. So I guess what I'm recommending is 24K for the resistor, and I went ahead and just used a 2-watt Vichy, one of those pro resistors. That's what I use for everything. And I feel like, just like with my wire sizing, by using 2-watt resistors when you could probably use a quarter or a half a watt, you get more surface area in the resistor itself, and you get a cleaner signal through it with less noise and problems. And it avoids you having to go buy a $10 fancy carbon film something, whatever, trying to get some magic sound. You can get that same quality using a larger metal film resistor, which doesn't cost any more than a half-watt one does. And there's plenty of room inside these amplifiers to just use 2-watt resistors for everything. And then if you need to, that one resistor needs to be a 3-watt. And obviously the cathode resistors need to be 1 watt so they can act like a fuse. Anyway, back to the global negative feedback. 24K, and then try from 110 PF to 330 PF. Don't go higher than that, and I wouldn't bother going lower than that. Maybe buy a 110, a 220, and a 330, and give each one a try and listen to it. And audition each value and see which one sounds best in your system. That capacitor in the global negative feedback circuit on this amp feels like it's the real tuning tool to changing the tone on what it sounds like. And you can see on the audio analyzer suite frequency response testing we did with no capacitor, the high end goes whoop, and then on the one with the 330 PF, the high end rolls off. And I have a feeling the 220 is going to be right in the middle. But again, ran out of time, didn't have the parts here, would have had to make a Mauser order for 2 capacitors and wait several days, and the guy wanted his amp back. So some of this is going to be speculation. Some of this you guys are going to test for us and can leave comments below or on some of the forums that talk about these amps. So I hope y'all will play with that. So that really wraps up the R8. Like I said, it's not here. Bench is empty. It's over at his house. We're not doing any more work on it. Probably going to be one more video where I do kind of a overall overview of the amp, the mods I did, what order you should do them in as far as importance, which ones are kind of optional, which ones are must do, all that kind of stuff. And that's going to wrap up the Willsenton R8. We're going to move on to other projects. So hope you're enjoying this content. Hope you're enjoying my channel. If you are, please subscribe. Please consider joining my Patreon or a donation at my website. Like the video, hit the bell, and we'll see you soon. Have a nice day.